Hey, AP Calc. I'm going to go over the week 5 exam review and just walk through each part of it. So it says no calculator is allowed for this question. Remember that all of the questions on this year's AP exam will be calculator allowed. All right, so the first one, we're given an implicitly defined function in terms of x and y, and they're asking us to show that the derivative simplifies to 2y minus 2x over 3y minus 2x. So just a little implicit differentiation review. So what I like to do is when we do implicit differentiation, we think of y as a function of x. So I would have 2x squared plus 3 f of x squared minus 4x times f of x equals 36. And I think that just makes it a little clearer when we have to use things like the chain rule. So if you feel really comfortable with implicit differentiation, you don't have to do that step. All right, but now I'm going to differentiate everything with respect to x. So let's see what we end up with. Derivative of 2x squared would then just be 4x plus, now here I would have to use the chain rule. So I'm going to bring derivative of the outside. That's going to be 6 times f of x times f prime of x. So derivative of the inside. And then for this one, I'm going to have to use product rule. So let's do minus 4 times f of x. So that's the derivative of the first term. And then it would be plus negative 4x, so I'm still just going to do minus 4 f prime. And that's going to be equal to 0. This derivative of a constant is 0. So now I like to go back to just strictly terms of y. So what I have is 4x plus 6y times y prime minus 4y minus 4xy prime equals 0. All right, so at this point, what we're trying to do is isolate the y prime. Remember that y prime equals dy dx. We have multiple y primes, so we're going to group those on one side. We're going to move everything else to the other side. So I'm going to have 6y times y prime minus 4xy prime equals, let's add the 4y over, let's subtract the 4x over. All right, now what we're going to do is factor out the y prime. We'll have 6y minus 4x left over. And then we'll just divide that out of both sides. So divide out the 6y minus 4x. Divide out the 6y minus 4x. And we're left with y prime equals. Now on the right, I can divide 2 out of everything. So that would be 2, 2, 3, 2. And so what I end up with is y prime equals 2y minus 2x over 3y minus 2x. And that's exactly what they wanted us to show, right? All right. There's part A. Let's move on to part B. Find the slope of the tangent line to the curve at each point where x equals 6. All right, so to be able to find the slope of a tangent line, we're going to want to be able to fill in x and y in this derivative, right? That's what a derivative is. It's a slope. So I know that I want x to be 6. So that's the first thing I'm going to do. I'm going to plug in 6 to my equation here for x. So we're going to have 2 times 6 squared plus 3y squared equals 4 times 6 times y. Nope, not equals. Minus 4 times 6 times y equals 36. Okay? So let's simplify that a little bit. What do we have here? 6 squared is 36. So 72 plus 3y squared minus 24y equals 36. So that's going to come out to a trinomial that's, let's see, 3y squared minus 24y. And if I subtract the 36 from the other side, I get plus 36 equals 0. All right, so let's go to this page. So I have 3y squared minus 24y plus 36 equals 0, yeah? All right. So now I want to solve for y in this case. Here I can just divide 3 out of both sides. That's going to be y squared minus 8y plus 12 equals 0. This is actually going to factor. Right? Yeah. Y minus 6 times y minus 2. All right, so we get y equals 6 or 2. So the coordinates then that we have are when x equals 6. Coordinates that we can look at are 6, 6, and 6, 2. And we're just going to take that to our slope formula, which was 2y minus 2x over 3y minus 2x. So dy dx equals 2y minus 2x over 3y minus 2x. So that's y prime. So let's look at, I'll say y prime at 6, 6. So just function notation. So 2 times 6 minus 2 times 6 over 3 times 6 over minus 2 times 6 rather. Doesn't really matter what the denominator is as long as it's not 0, but our slope comes out to 0 there. And then let's look at y prime at 6, 2. So we get 2 times 2 minus 2 times 6 over 3 times 2 minus 2 times 6. So what is that? In the numerator we have 4 minus 12 is negative 8. In the denominator we have 6 minus 12 is negative 6. So this is positive 4 over 3. All right, C, find the positive value of x at which the curve has a vertical tangent. Show the work that leads to your answer. Okay, so a vertical tangent is undefined. So what we want to look at is when is dy dx, which is 2y minus 2x over 3y minus 2x undefined. So this is going to be undefined when the denominator equals 0, right? And I'm just trying to find the x coordinate. So what I'm going to do is isolate this in terms of y. So I'm going to say 3y equals 2x. So y equals 2/3 x. All right, so we need the case such that y equals 2/3 x. So we need another equation to plug into, to do a substitution into, to be able to get our answer here. All right, so what we're going to do then is go back to our original function, our original implicit function, which is 2x squared plus 3y squared minus 4xy equals 36. So hold on. So 2x squared plus 3y squared minus 4xy equals 36. And all I'm going to do is take that y equals 2/3 x, and I'm going to replace the y's in this equation with 2/3 x. So I'm actually going to have 2x squared plus 3 times 2/3 x quantity squared minus 4 times x times 2/3 x equals 36. Okay, so we have 2x squared plus that 3 times 4 over 9, 12 over 9x squared minus 8 over 3x squared equals 36. Okay, I'm going to kind of do this all at once, but you'll notice that these are all like terms. This is something that you could do in your calculator. But if you isolate x squared, you're going to end up with x squared equals 54. So x equals root 54, sorry. All right. So last part, let x and y be functions of t that are related by that original equation. At time t equals 1, the value of x is 2, the value of y is negative 2, and the value of dy dt is 4. Find the value of dx dt at time t equals 1. Okay, so this one sounds kind of crazy. It's not too bad, though. Here's what they're saying. They're saying both x and y are functions of time. So we can go back in and rewrite that equation kind of this way. It's really 2x of t squared plus 3y of t squared minus 4x of t y of t, of t, equals 36. So then they say when t is 1, the value of x is 2, y is negative 2, and dy dt is 4. So find the value of dx dt. So basically what they're wanting us to do, we're going to go through and differentiate everything with respect to time. So this is going to be d dt on both sides. So let's see what we get here. For this first one, we're going to have to use chain rule. So derivative of the outside is 4x of t times x prime of t, or dx dt. Same thing here, plus 6y of t times y prime of t, or dy dt if you wish. Minus, now here I'm going to have to use chain rule, or product rule rather. So that's going to be, let's see, 4x prime of t times y of t plus 4x of t, y prime of t, and then equals, derivative of 36 is 0. So now what we can do is plug in 1 for t. So I'm going to have 4 times x of 1 times x prime at 1 plus 6 times y of 1 times y prime at 1 minus 4 x prime of 1, y of 1, plus 4 x of 1, y prime of 1, equals 0. And they've given us a bunch of that information. They said at time t equals 1, x is 2, y is negative 2, and dy dt, which is the same as y prime, is 4. So let's just go fill those in. So, all right, what we have is 4. X at 1 is 2, so 4 times 2 times x prime at 1. This is what we're looking for. We're looking for x prime at 1, which is dx dt at time 1. So plus 6 times y at 1 is negative 2, and y prime, or dy dt, is 4, minus 4 times, again, x prime at 1 is what we're trying to figure out. Y at 1 is negative 2 plus 4x at 1 is 2, and y prime at 1 is 4. So this is all equal to 0. So what you'll notice, hopefully, here is that our only unknowns, x prime, everything else is just a constant. So we can multiply this all out, isolate the x prime, And doing that, I'm just going to jump to the answer here, which you get x prime at 1 equals 5. So just a little bit of computation at that point. Okay, that's it. Hope that helped.